Good afternoon. I'd like to welcome you to the last session of our 2015 National Primary Care Week celebration. How many of you have been to other sessions this week? Okay, great. I think we've had a really spectacular group of, Corey's saying yes, he's been here for all of them. At any rate, I think we've had a really spectacular group of presentations this year and hope you've enjoyed them. I do want to say that yesterday I did not give credit to the groups that sponsored lunch for yesterday, and so NAPA and the OB-GYN Society, do we have representatives from those groups here? Stand up and let's give you a thank you for sponsoring that. Really appreciate that, and I think that was a really good program. And also our Northeast AHEC friends back in the back who are working on getting the word out more about HPV vaccination. So glad to have them here as well. Today's program is a result of some hard work by Rose Glassiter. And I want to really thank her for this. It was kind of a surprise topic to us when we started looking at what was the theme for the year, and it is climate change as far as the AMSA National Primary Care Week site and plans are going. So really pleased that she was able to pull together a really quality presentation with that I'll let her introduce. So Rose.
Hi everybody, thanks everyone for coming. Like Janet said, the theme of National Primary Care Week is climate change and healthcare. So today we have two great speakers. First we'll have Doug Cluck, who drove all the way from Kansas City this morning. Doug is the NOAA, or the National Oceanic and Atmospheric Administration's Regional Climate Services Director for the Central Region, which includes many states in the Central North, including Missouri, plus 13 others. So he'll be speaking kind of generally about climate change and human health. And then we have Dr. Alicia Wodeka, who is a professor in the Health and Exercise Sciences Department at Truman, and she'll be speaking about more public health perspective and specifically heat waves. All right, so without further ado, and then following this talk, if anyone has questions, we can pass around a mic for any questions. And this can clip on your...
I'll just throw it here. That's easiest.
Okay.
Thank you, Rose, for inviting me, and thanks to the school for allowing me to get up here and talk. It's, you never believe weathermen and climatologists no matter what we say anyway, but that's okay. You still read our forecasts, and you may make a decision or two based on them. I have no background in health sciences at all, so bear with me when I get into some of these topics. It's going to be pretty broad brush. I'm going to start off with just a quick discussion of sort of the elements of climate change and some of the things that we're seeing. You may be able to tie better into your field than certainly I can and say, well, that may matter. In some cases, I may be missing some of this. I'm going to talk mostly about this report, the National Climate Assessment, which comes out or has come out about every 5 years or so. The Congress has told us that this needs to be done, and we need to assess sort of how the nation's doing, some of the implications and some of the impacts of climate change in the U.S. So this report is available online at, and she has little teeny reports, little quick summaries, if you will, executive summaries. And there's not that many people in here, so some of you will actually get one. I brought, I think, 20 copies or so. Okay, so I don't want to talk too much about myself, and we'll get into this stuff here really quick. So this report, I'll talk about that just a little bit, is broken out in a couple different ways. So if you're not interested in what's going on in the Southwest, and you may not be, you can sort of look at the Midwest section or any other area to learn a little bit more about the geographic region. You can also, it's also broken down by sectors. So there is actually a human health sector. And a lot of the material that I'm pulling out of this talk will be from that. It won't have everything, and if really you want more detail and you want to see the papers that the findings came from, it's all online. It's all there. Everything you could possibly want. So if you have to write a paper on climate change and health or whatever, this is a great place to start. Okay? There's a few other things, a few other tools that I'm going to talk about later that could be useful if I can get through all my slides. I have too many, so I'll keep going fast. So you've probably all heard this. Climate change is occurring. It's been going on basically since the internal combustion engine and such, ever since we've been releasing a lot of CO2 into the atmosphere. This is just simply a CO2 graph. This is the CO2 parts per million. And it's also good speaking to a scientific group because I can say things like parts per million and you guys automatically know what I'm talking about. This is the CO2 graph as it goes up in the atmosphere. We've been measuring it for quite a few years. And the red line, or the red and blue lines are indicate the temperatures of the Earth. Either we're above or below this sort of normal line here. And dating back from 1880 until near the present. I think we're missing a couple years off of here. It hasn't been updated for 2 or 3 years. Basically, the message is global warming past 50 years, primarily due to human activities, and beyond that, actually. Here are some of the proxy, if you will, proxy data that we have on climate change. Some of the things that are happening. These are trends that we see in different aspects of the atmosphere as well as the land surface. Things like certain glaciers, most glaciers actually retreating, less snow cover generally, temperature over the land going up, sea level rise being indicated around the world, ocean heat content increasing, sea ice decreasing, especially in the northern, in the Arctic, and sea surface temperatures also rising, et cetera, et cetera. Here's the observed temperature change over the US and the past 22 years compared to the last 60 years before that. You can see where it's darker red, you see the greater increases, and this is sort of expected. And as you go north, this trend continues to warmer and warmer as you move north into Canada and to the North Pole. The change isn't warmer necessarily in Minnesota than it is in Texas. It's just the degree of change has been greater in the warming cycle. This is sort of a depiction, if you will. It's not a prediction, it's more of a scenario based on how much CO2 is going to be released into, and other greenhouse gases released into the atmosphere. This is sort of a worst case scenario by the end of this century. We're looking at temperatures, especially in the middle part of the country, 9, 10, and in some cases, I don't know where the 15s are, I think here and somewhere up there, degrees warmer on an annual basis than we have in the past. And that certainly would be bad. And this is if we continue to put out emissions, CO2 emissions and other greenhouse gas emissions like we do today. And this is this is what's going to happen, the scenario anyway, of what the models would tell you, something like 2 to 3, in some cases 4 degrees at the most, rise in temperature over the entire year. But that's a lot, and it's hard to describe the difference between each one of those degrees. As you go up 1 degree, the impacts are pretty large, actually. That'd be a good presentation in and of itself. Here's trends in U.S. precipitation. Just looking at precipitation over the last, last few years compared to the early part of the century. It's become a lot wetter in some areas, drier in some other areas. Again, these trends, precipitation is a lot harder to predict on a global scale and model, that kind of thing. So all I'm showing you is this is the trends. The Midwest has definitely gotten wetter. If you're from around here, you'll know, especially if you're in Iowa and Missouri this year, at least northern Missouri, it was pretty darn wet here earlier this summer. Now it's dried out quite a bit since then. But the trend, annual trend, again, over this period has been generally wetter in recent years. Observed change in very heavy precipitation, and what we've seen in these cases are more instances of heavy rainfall events. When rain falls, it falls hard, as opposed to a few tenths of an inch. We're getting higher frequency of heavy precipitation. Around here, that might mean more often you're getting 2+ inches of rain in one shot rather than those 2 inches spread across a month or something like that. So this is showing where in the U.S. those increases are the greatest, and you see the Northeast has seen a lot more, and the Midwest has seen quite a bit more as well. Again, you can think back just the last few years, probably the last 10 years or so, or more, and notice an increase of precipitation in a lot of areas around here, or heavy precipitation events around here. This is also goes along with the past data. The magnitudes of floods, trends in flood magnitude have been greater. Again, so kind of centered on the Midwest and the Northeast. Again, not surprising. If you have heavy rainfall events, you're going to have more flooding, and both of those papers sort of indicate the same thing. So 2014, that's last year, in case you're taking notes. Last year was the warmest year on record, according to ocean and land surface measurements. 2015 is going to beat it. That's my prediction. It's likely it's going to beat it. There's a bunch of reasons for that besides global climate change. It's also an El Nino year, which means a lot of the ocean is warmer than it normally is. Some parts are a little cooler, but there's a lot more warmth in the ocean than there normally is. We can talk about those repercussions at maybe a different, what the meaning of an El Nino means at a different time, because it would take a little bit of explanation. I do have an outlook in here for El Nino, so you'll see it eventually. So this comes right out of the report. Climate change threatens human health, well-being, many ways. Increased here, and here's sort of the litany, if you will, of kind of issues that could impact human health. Increased extreme weather events like flooding, heavy rains, wildfire, as we're seeing in the West and parts of the East occasionally, decreased air quality, threats to mental health. That can be for a lot of reasons, by the way. And illness transmitted by food, water, disease carriers such as mosquitoes and ticks. And some of those health impacts are already underway in the US. And I'm sure you're going to be familiar with a bunch of these. In the Midwest, and I didn't know, you folks are probably from all over the US, right? You're not just from the Midwest, you're from everywhere. But I picked an area, okay? So we're in the Midwest, so I'm gonna pick on the Midwest. So we have seen definitely an increase in heavy rainfall events, increase in heavy precipitation frequency, mostly in urbanized area for a lot of reasons. Climate change is part of that factor. Increase in number of degree days above 90 degrees. And really what we should be saying here is a number of, you should really take into account temperature and humidity when you're looking at that, because if it doesn't get to 100 degrees, but the humidity is such that you're causing a lot of suffering and heat stress, it doesn't really matter what the real temperature is, as long as you build into the equation some of that moisture. And then social and economic impacts and agricultural gains and losses are other issues. I think Alicia is going to talk a little bit more about heat and heat waves, so I'm going to just go through this very quickly, being that a major concern in metropolitan areas. Less so as you get away from big cities, and even in 1995 in Chicago is probably one of the best. Most of you probably, who was alive in 1995? A few of you. Okay. Well, if you remember, in 1995 there was a terrible heat wave in Chicago, and it killed hundreds of people. So that's sort of what people always point to. And in 2003 or 4, it was in Paris, or in France, in parts of Europe, where they had a heat wave that killed quite a few people. Okay, get away from the heat there. No, we're not going to get away quite yet. This is simply like the last map I showed. If we reduce emissions, we're still looking at warming, change in hottest days. We're still going to have hotter days no matter what we do. It's already built into our Earth atmosphere system, an ocean system for that matter. And this is if we continue putting out the same emissions as we always have. So, and this would be really devastating, to be honest. The problem is you might build an air conditioner to keep yourself cool. That's easy, right? But you're going to be putting more emissions into the air in taxing those. It takes a lot more energy to cool you off than it does heat you up, by the way, in case you didn't know. Excuse me. Asthma. Now, this is New York City down here and surrounding counties. They've seen increases, some increases in terms of of asthma. I think across the country it's been noted, but climate change is projected to worsen those effects due to heat, due to bad air, ozone, that kind of stuff. So people at risk will be more at risk than they were in the past. And I guess and it matters where you live, in that region anyway. This is one study. Probably do this in Chicago and lots of other places and come up with similar results. And to be honest with you, I cannot remember what those percentages are. It's just probably a growth of the number of people affected. Here's I guess along the same lines, allergy ragweed pollen season has lengthened. Change in ragweed season, length of days. This is what has happened so far. Okay, this year's a good example. We haven't had a hard freeze. We haven't had a good freeze to kill everything off, right? In some ways, that's sort of depressing. But if you're you have allergies, it's not depressing at all. You're begging for that. And we've actually seen some of the longest, some of the latest days of the year, this year, in terms of some places up to our north that usually have a frost by now, frost or a freeze. So they're kind of getting, they're setting records, if you will, on the latest freeze or hard freeze that they've had. So people continue to suffer. This isn't going to change anytime soon. Excuse me. And will get worse, the number of days. And you can notice as you go north, the number of days increases. Not sure what this means down here with these slightly negative numbers. The other issue is smoke from wildfires or any fires at all. This is an example of smoke that came out of Quebec, went more or less straight south into highly populated areas of the US. And I don't know what the repercussions necessarily were, but this is showing that we had similar things this summer. It was a lot higher, so we probably didn't breathe a lot of it. If you remember, I think it was June, that we had hazy skies, and I even wondered, why is it so hazy? What's going on here? I went home and looked at the satellite picture, and you could see from way up in Alaska and central Canada, the airflow was directly down over the top of us, and they had huge fires up there. Again, it was probably at 10,000 feet, or higher, and we didn't actually breathe it, but it could, especially if it came from the west. And certain people, certain populations are more at risk for that. And this is projected changes in particular tick habitat. I know we have ticks already all around. I grew up in Nebraska most of my life, but I'm not sure why this doesn't indicate, and this may be a particular species, but this is for, I think, ticks that carry Lyme disease and such. And these are projections to show the spread of that. The spread of that northward, and so actually getting better as time goes on in the south. And I'm not sure why that would be, why the ticks would necessarily be less down there. Maybe because they can't stand the heat. Okay, we've already talked about projected changes, and I'll just, here's sort of the implications of those heavy rains that we were talking about a little bit earlier. Streams and rivers rise, flooding homes, businesses, blah, blah, blah. That's always a bad thing. But sewer and water systems also can't handle that. They're not built to handle that. It's built for a certain, engineers built it based on a certain range of potentials, and we're exceeding those potentials more and more often. So rebuilding infrastructure is going to be a big deal. Floodwaters can become contaminated, as we all know. Agricultural waste, as well as chemicals, raw sewage, and other pollutants get into the waterways, cause all kinds of health problems. For people and animals and ecosystems, of course. And then there's mold issues. There are disease-causing bacteria and viruses. And we already talked about sewage overflows already. So that's one of the problems with the heavy downpours. Another thing you may know a little bit about, if you ever go out, this is Lake Erie, but if you ever go out and look at a farm pond, or even around here, is you'll see these algal blooms at some point during the season, especially the smaller ponds. This is a huge one, and this is from, I think, this 2011, but we've had one last year, and I think they had another one this year. I think it was last year that Cleveland had to shut off their water supply. And now you're talking about a lot of people not being able to get water, and that's devastating and worrisome to a lot of people. Where does that come from? it directly comes from phosphorus and other things off of agricultural lands that get heavy rain, wash it down, and cause such problems. Again, it's ecosystems and human beings impacted by this. It's basically a bacteria that's poisonous. Most vulnerable at most risk, and not a big surprise. Those people who with the least means tend to take the brunt of a lot of these climate change impacts, I guess you could say. And so you can see here vulnerable people, including children, elderly, the sick, and some communities of color and the poor, tend to pay the cost first. And this, you probably can't see a lot of this, but this is how people are aging in the U.S., predictions of age groups. We're going to have a lot more older people as we go along. Asthma rates have been increasing, chronic respiratory disease deaths, obesity rates in children and adolescents, I guess it says, have risen quite a bit. Poverty in the U.S. Maybe on the rise, diagnosed diabetes, period. All these are complicated, if you could argue, by changes in the climate. I guess I'll skip over that. That's just showing where people left and why that can be an issue. If you have people migrating out of certain areas because of hurricane damage or various other climate issues. I think sea level rise is going to be one of those issues. It's going to happen sort of slowly, but there will be a lot of people moving directly off the ocean for lots of reasons. So prevention, public health actions, especially preparedness and prevention, can do much to protect people, and I bet we're going to hear that again. Early action, so we don't do that very well, preparing. People don't want to spend money on things that haven't happened yet. We usually sort of react as opposed to plan ahead of time and be prepared. That probably is not a message you are not unfamiliar with as well. As threats increase, our ability to adapt in the future may be limited, which is a good thing to say. And when you look at like a Katrina or something like that, no one was prepared for Katrina the way it happened. Responses have multiple benefits. So responding to climate change provides opportunities for human health across sectors, including energy and agriculture. So there's other beneficiaries of being prepared from a human health point of view. Strategies vary in benefits is protecting people from combating climate change and providing other societal benefits. I'm going to go through tools really fast. So I don't care what you do with this PowerPoint. You can distribute it however you like. Just take my name off now. But what I will say is some of these tools may have nothing to do with what you're interested in or never do you any good, but I'm going to just tell you that they're available, okay? So really fast, this is my home office, if you will, in Asheville. It's in Asheville, North Carolina. I am based in Kansas City. But you can get these maps that show what has happened state by state, for example. September 2015, right, last month. These red states have nothing to do with politics, but these red states all indicate where they've never been warmer they've never been warmer in 121 years in any of those states in September. Now, what's the repercussion of that from a health point of view? I'm not sure. But this at least provides maybe answers to why things have happened. You may want to use this website down here. It's called State of the Climate, by the way. And you can go back and look at other months. You don't have to just look at September. And here's September. This is looking at precipitation. Where has it been wet? Where has it been dry? It's a little hard to see, but these are rankings in here. This 121 means record warmest. And if we had any blue whatsoever, that would you would see that those are below normal temperatures across the U.S. Okay. If I hope that makes some sense to you. So we're ranking 121 years, next year will be 122 years, on how warm it is in this particular month by state. And there's several depictions of that. Let me just go forward here. Here's January through September of this year. It's never been warmer in those states for that time period in the historical record dating back to 1895. there's no other record cold or anything else, but these are very warm states. These are kind of trending warm. It's very warm also, has been warm in Florida as well. As far as precipitation, this shows that it's been, these light brown and light yellow colors show you where it's been drier than normal. Again, who knows? Maybe there's a hantavirus thing you're trying to track. Maybe you want to go and look at these things. I don't know. This is for the year so far, January to September. That last one was just September. This shows that it's been relatively wet down here for the year in these places, these green areas, and very dry in some of these western areas. If you want to look at this more regionally, you can go to the High Plains Regional Climate Center, and they have all these wonderful maps. And here's Missouri, if you can't see it. This just shows in the last 30 days, the percent of normal precipitation. Ours was around 5 to, it's been very dry. How about that? And these blobs where it's purple show that it's been very wet. Again, I don't know if this is going to do you any good, but there are tools out there to look at different aspects of climate. Here's departure from normal temperature over the same region. Generally showing that if it's yellow or towards red, it's warmer than normal, which not a big surprise. There's the percentage of normal precipitation for Missouri, very dry. Okay, we also do, very quickly, I'll say this, how much time? Wow, okay, so we do webinars. There's actually going to be one at 1 o'clock today across that, of course, the north central part of the US. We talk about climate issues, climate summary. We don't talk a lot about human health. If you want to tune into those, you can go down and sign up at this place right there, find out about your climate, what's happened in the last, say, 90 days and what's going to be happening over the next 90 days. That's what those do. We do put out these nice little brochures talking on a quarterly basis, talking about, in this case, it's the Great Lakes, Missouri Basin, and Midwest region, and it's done for these other regions across the country. Again, it gives you a synopsis, a 2-page, not meant for the climatologist, really meant for the layman to understand more about what's going on in your neck of the woods and what the outlook is. Here's the El Nino thing I was going to tell you about. There was a forecast just released today, this morning, that I don't have updated, but it doesn't vary from this very much. A quick and dirty of this is December, January, February outlook for basically this winter, okay? Showing that everything above this 33 line here is, the probabilities are enhanced to be warmer than normal. The probabilities get stronger as you go north. Cooler than normal as you head south. Chances are greater for. Same with chances are better where you see green for above normal precipitation, December, January, February, and below normal precipitation in these areas. And again, we put out these nice little 2-pager things. I'll end with this thing. If you don't get anything else out of this talk, go to the Climate Resilience Toolkit. It is a combination of several federal agencies and others working together to put all their climate change material in one place, which is very rare in the federal government to everybody work together. And so EPA is in there, BIA, believe it or not, Bureau of Indian Affairs, NOAA has stuff in there, but they're tools to help you or anybody identify the problem, determine vulnerability. There's a step-by-step process to go through to help you with your issues. If it's sea level rise, if it's human health related. So I grabbed this page really fast, building healthcare sector resilience, and I should have gone down a little bit more, but here's the beginning of the list of some of the things that would have, some of the tools that they have available, again, across the federal agencies and others that are currently available that may be useful to you if you're coming up with some kind of preparedness plan or whatever, or if you have to do a report. CRT, Climate Resilience Toolkit. Great place to go get stuff. There's some national resources, there's some regional resources, and there's the El Nino. And sorry I took so long. Questions will have to be later, I guess, right? Yeah.
Thank you. So we might just stay right here. Okay, that's fine. Yes, I think we have this clicker thing, but I don't know how that's going to work with you. Okay. All right. Okay. All right. Thank you. All
All right, good afternoon. Thank you for inviting me here to talk. This is a topic that is very important to me. It's something that I never thought I would be able to study. My background is in biology, and then I did a little bit of a switch when I did my PhD, and it was in health education. And so when I took a climatology class there just out of interest, I was able to combine everything that I was studying, and that was absolutely amazing. And so my topic today is with heat waves and climate change, so going a little bit more specific, looking at local preparedness on a global issue. And so I am using a Prezi, and so we'll see. Hopefully it doesn't cause any motion sickness. I'm sort of torn with these and using these to teach because they sort of fly around the screen, so hopefully it doesn't cause anything with that. And it flies around. So what I wanted to do today is to talk about what are heat waves, because there are so many definitions actually for what this weather phenomena is. I wanted to identify how they impact human health, which you will know a lot about already, probably. I wanted to also identify social ecological impacts of heat waves, and then identify how climate change can exacerbate their occurrence and their variability. So just looking at these two pictures of weather phenomena, so we have there the Joplin tornado that occurred in 2011 and a picture of hurricane or superstorm Sandy in 2012. And so just looking at the Joplin tornado picture, for example, what type of phrases come to mind when you see that? You can shout them out. Ominous. Okay. It is, yes, it is frightening. That is terrifying. That would be terrifying to me if I saw that coming at me. And so absolutely, so they're definitely terrifying. In Joplin, 158 people were killed during that event. It caused $2.8 billion in damages. With Hurricane Sandy, that was a Category 3 hurricane. It affected 8 countries and killed 200 people in 8 countries collectively. But when we look at heat waves, this is a picture of the Midwest heat wave in 1995, the Chicago heat wave that Doug had mentioned. And so here, they're not as pictorially devastating. It's something where the perceived risk is pretty low. They're defined as extreme events characterized by several days of temperatures greater than 90 degrees Fahrenheit. And this is the CDC's definition. They're stagnant air masses, which means they don't move, and that's why there's consecutive days. And usually the nights have higher than usual minimum temperatures, and that is something that's really important for these phenomenon. In the US, mortality rate from heat waves is about 700 people every year. And so when I say that, and the reason I show those previous images is because that's more than tornadoes and earthquakes and some of the other weather phenomena that we experience within the US. Without any reduction in our carbon emissions, and this is based on computer modeling, and this is by 2050, heat mortality is expected to increase to the thousands every year. So when we're thinking about the health implications of this, the greatest causes is exacerbations of current medical issues, which we'll identify. Anything from cardiovascular disease, respiratory issues, renal disease, that studies have identified get even worse during heat events. But then also just direct effects from heat exhaustion and heat stroke. In Chicago, 1995, as Doug had mentioned, this was one of the, even though heat waves have existed for hundreds of years, this is not a new phenomenon, but at the same time, this was one that really showed how vulnerable we were, especially within our public health system. So 19 states were affected, but Chicago was very much devastated. Milwaukee and St. Louis were affected as well. They had 5 days sustained temperatures of over 104 degrees. So obviously you can imagine extreme dehydration, heat exhaustion, and heat stroke, with at least 3,000 more visits to the ERs than was already seen in Chicago, which would generally be a lot. During this time, 700 people were killed during this event. Most of them were over the age of 65. Most of them were socially isolated, so living alone, so people were not checking on them. And this was just one of the many things that went wrong here. In Chicago, because of this event, everyone was using any sort of air conditioning that they had, so there was tons of power outages. There was people illegally opening water mains to try and get more water, and just, because everyone was so hot, so then obviously caused a decrease in the pressure. I mean, it was a disaster. It was an absolute disaster, and with the communication from the city and in general. So then, of course, as Doug had mentioned as well, in the European heat wave in 2003 occurred. And so those numbers, that is the estimations, but what was originally reported was that just hundreds of people were affected. But 30 to 40,000 is what is estimated, with some estimations as high as 70,000. And again, that was individuals who were either socially isolated or within nursing homes. It was people over the age of 65 that were most impacted, especially in France. And the major cause was the lack of air conditioning. It's not widely used as much as it is here in Europe, and that's why it was such a big deal. Oops, sorry. And so, as Doug had mentioned as well, here are some of the populations at risk. So within climate change, but then also for heat waves. So they're elderly first and foremost because of lack of temperature regulation, the medications that they might be using, and also because of chronic diseases that they might be experiencing as well. Children, because of, if they're not able to get to, the autonomy to get to places, a lot of issues with being left in vehicles, which public health has really tried to step up with that. Those who are immunocompromised, people who work or are active outdoors for obvious reasons. And then different populations might be at risk depending on their geographical location. Places that are just not used to extreme heat might be more at risk than those that experience intense heat on a seasonal basis. But socioeconomic status is a huge indicator for heat waves. And so just to give you a couple of studies, in the 1966 heat wave in St. Louis, regarding mortality, 25 per 100,000 people who were Caucasian died during the event versus 32 per 100,000 who were African American. And so we continue to see this. So heat wave mortality disproportionately affects individuals in impoverished conditions. And another example with that is is regarding income. So a 2007 study found that individuals who make $20,000 or less, 35% of them were less likely to know about heat wave warning systems or that they existed in general, versus those who made $60,000 to $80,000, 10% were less likely to know. So there's a disparity in the income level. This is just a general timeline of heat waves that have occurred in the Midwest. I know, as Doug had asked, a lot of you may not be familiar with this area, but this is the area of focus for this presentation and a lot of my research. And so in the parentheses is the amount of people that were killed during the event, or the numbers. And there's a lot of discrepancy with the way things are reported because of the epidemiological implications behind what might cause some of these deaths. So was heat, an underlying cause, or how was that discerned on a death certificate? And that's a whole different discussion altogether right there. But what I want to point out here, and hopefully you can see at the bottom where it says 1979 to 1999, that was about 8,000 deaths over that 20-year period. But within a 10-year period, almost that same amount between 1999 and 2009, with 7,800 deaths from heat. So just a little bit more information about urban areas. And so heat waves are particularly dangerous in urban communities. And so the reason is because there's less vegetation, you have more blacktop, human body mass. So this amplifies the temperature even more so in St. Louis and versus what we would experience in Kirksville. And so it's something where you can see the 3.3 billion people are living in an urban area, and this number is expected to increase by 2030. A majority of the heat wave responses that we've seen within public health are primarily focused in urban areas because of this reason, but even within rural areas, it's definitely of concern as well. And so this is just information on heat wave warning systems. A lot of the key players with this, you would think are in public health, but they are all over. It is so important to have everyone on board, from clinicians to the media, you name it. And so the primary aim is to obviously reduce mortality, but then morbidity and the excess hospital visits that could have been reduced or eliminated altogether. And so there's individual and community responses here. And so from an individual response, that is everything that we can do in being knowledgeable about the current weather patterns, even if it is an inconvenience to us in our plans for that day. And then knowing, as one of my participants said during my dissertation, he worked at a larger city health department and said they try to get the information out about Who are you? What are you doing? And what are you putting into your body? Essentially, who are you knowing? How old are you? What are you doing? How are you, do you have any health conditions that you should make sure you're aware of during these extreme weather events? What types of activities are you doing? Is it more strenuous that you're more at risk for heat exhaustion or heat stroke? And then what are you putting into your body? Are you taking medications that are putting you more at risk for dehydration or other things? Drugs or alcohol especially are very important. And then with community, as you can see, the partners are absolutely essential with heat wave planning or any type of public health planning for all hazards events of any type of weather phenomena. The media is listed on there, but that can sort of help or hinder depending on what the topic is. The emergency management agencies, and that's what EMA is, should be there for every county. Churches, very important. Schools, obviously, our weather agencies, emergency responders at multiple levels, PSAs, and seasonal information. Heat waves are no surprise to us. We know the weather is going to get warmer every summer, and yet it still catches us off guard. And so this is something, and especially as I talk about with climate change, becomes very, very important. So with hospital visits, this I wanted to share with you. This is just 2 newer studies that are out. They looked at a little bit older data though. And so for the first one with hospital admissions, and so this was something they researched 114 different hospitals and cities, and they found that there was a 3% increase of individuals over the age of 65 during heat events, particularly for renal diseases and then respiratory disease, as you can see up there. And then another study in 2015, this was published in 2015, but they were looking at 2011 data from Houston, Texas, and found a 3.6 excess risk increase from heat waves for different types of issues. So as we're here today and talking about climate change, what happens when you add that into this mixture? So creating these bad situations and essentially making them worse. And regardless of the scenario, so when we're looking at climate modeling, which is an incredibly complex process, regardless if we're looking at scenarios, it's showing average temperatures are increasing, but then also, and this is the really important thing, is the issue with variability. So not only are they more likely to occur for longer periods, so more days on average in a row, which is very devastating, but then also showing up when we are not ready for them. It's not July, it may be April. And so this is something where these are what they're looking at for these scenarios, which is trying to amp up our public health preparedness from there. And so this is some information with climate change. The Union of Concerned Scientists put out this report in 2012. And so they were looking at data trends from 1946 to 2011. And so what they found was that there was an increase on average by 200% for St. Louis and Columbia, Missouri. So this is an average of an extra 10 days of intensive heat and 3.5 days for Detroit, Michigan. And so it's extremely likely that anthropogenic or human-caused climate change at least quadrupled the risk for extreme summer heat events that occurred in Europe in 2003. And we can continue to see that with the extreme heat that Germany and other portions of Europe faced this summer as well. And so as Doug had mentioned, immense implications when we're thinking about not just heat, but drought, and what does that do to agriculture, and what does that do to undernutrition, migration and displacement of people, and then also disease. So very, very important in multiple aspects. And so one of the last things that I have up here is just resources, because there's a lot of information out there, and there's a lot of excellent information in regards to understanding more about the health risks for extreme heat. The CDC has great info. NOAA obviously has wonderful information just about climate change in general, wanting to get more knowledge about that. The Intergovernmental Panel on Climate Change is phenomenal, and they have great things on their websites. Just different information about heat programs, about getting involved with more of those, whether it's from a health department or any locality. The EPA puts out an extreme heat events guidebook. And then also the city of Kansas City has wonderful resources for their heat preparedness, and then also St. Louis, Missouri. A majority of cities really stepped up after 1995 because of the implications that it caused. But I actually was just reading this today, and I wanted to bring it. I didn't have enough time to put it in here. the American Public Health Association just has this newsletter and put it out regarding a new book that's out called Climate Change and Human Health. And so it's specifically for medical clinicians. And so it just seems really fascinating. I have not read it as of yet, but it's by George Luber and another author, and they're just phenomenal in the CDC and then also co-working with the National Environmental Health Association. So lots of really great information out there. But that is what I have, and so I know we didn't get to have any questions for you, but ended pretty early for questions. So I know you said you had the microphone if people do. Or
I'll say something just to get started. Pakistan and India
yeah.
had a pretty devastating heat event.
Right. And I didn't even focus on global events. Yeah, I mean, and that is something where, and the lack of, how preparedness is even done in those scenarios, lack of air conditioning, which is the primary, protective factor for issues like heat. So yeah, I didn't even go there, but yeah.
So for a majority of us who will be going into primary care, we're going to be dealing a lot with vulnerable populations, especially an elderly population. If we suspect one of our patients to be pretty vulnerable during the summer months, and they might live on their own or not be in a nursing home, so they have a lot of time by themselves, what are some ways that we can encourage them to kind of just be aware of the possibility of protecting themselves during those heat times, resources that we can give them that are attainable in the community itself?
That's a really great question. I think that one of the most important things is seeing if they have any sort of caregiving group at all, whether it's neighbors, and that can be just as important as people checking in on them. One of the biggest reasons, like with Chicago, it was areas that, one, didn't have air conditioning, but then kept their windows locked because of the crime rates within the area, so they were afraid to open the windows to let some of the heat out, causing just the increasing temperatures in the area. And in the city, people really don't check on each other. They don't. And so that's something where I think it's a big cultural shift as well. I mean, in rural areas, it's very different, in regards to how communities really take care of each other. So I think that knowing what resources that you have with wherever you're at in regards to the health department, I think that would be a really key one, whether it's a city or local health department, and then also the state health department, and then also any local agencies that you can call to help assist in checking in on that individual. But I think identifying if they have any just caregiving group would be the first and foremost.
There are also some geographic issues, and we didn't talk too much about that, but she mentioned places that aren't used to that kind of heat. That's going to become more prevalent than places like Detroit and Chicago, where they didn't used to have as much air conditioning, or places further north. That's been a big player, I guess, in the heat deaths.
Yeah, I mean, well, and another thing, like with the perception of risk being lower, it's like, it's just heat, it's just a little heat. It's not, this is a tornado versus like, this is, it happens every year. It's just a little heat, it's not a big deal. We'd survive without air conditioning, we don't need it, or just sort of lowering that risk, or perception of risk.
So I was really surprised to hear how many people are affected by heat versus, the tornado and hurricanes and stuff. Do we have any data on how the heat affects like our crops and how much more people is being affected by that? How many more people are being affected by the crop dying down because of the heat wave? I'm assuming those numbers just directly related to the like dehydration and stuff like that, killing off or people versus not getting access to food because
right. The numbers that I showed were direct from that event, or direct in the sense that if they had a medical condition that the heat made it worse, or direct that it caused heat stroke. But with other things, like when we're talking about drought, I mean those numbers specifically are probably more like scenarios of what could happen because of crop loss and other things.
So drought and death or medical issues often come into mental illness. And people, if you're a farmer, producer, or somebody who depends on water resources, whatever it is, really getting stressed. I mean, really having issues seeing their crop and whatever dying. that's where I've seen the most, just directly related to drought. Now, yes, crops dying, and in fact, heat stress on animals is a huge issue, and they're trying to figure that out, trying to figure out best ways to deal with that too. It's the same type of heat, long duration, warm nights, and it's really the minimum temperatures that when I show how temperatures are rising, it's not so much the high temperatures that you think are the big deal. It's the minimum temperatures not allowing the body, and there's a physiological reason for all of this, the body to cool off at night. The exact same thing with cattle. And some farmers have made a mistake in trying to sprinkle water on their cattle during the middle of a heat event. And what that does is it raises the heat index, if you will. Too much moisture in the air, and the cattle can drop over dead. And that happened in Nebraska a few years ago. Thousands of cattle just fell over dead because it was hot, stagnant, and the combination of heat, not that hot, maybe 90, but the erosion, the cattle couldn't cool, adding the moisture to the earth.
Right.
So, as students and future physicians, are there things that you would suggest that we can be involved with, or organizations to advocate for, or how would you suggest, like in our profession, to get involved with these issues to indirectly help our patients?
I think there's multiple things you can do in just the knowledge of these conditions in the first place. Like just that you're attending here, it speaks volumes about learning more about climate change, and then also things that can happen because of that. But then I also think just, knowing that you can definitely partner, and that it is so important to have clinicians partnering with public health or with, first responders or other things that are in how you can play a role during extreme events, whether it's something where it was an acute issue with a natural disaster or something man-made. I think that, just knowing that you can play a role in that and you can be a partner within your community, and to know what's going on within your community and the people that you're serving within that community is very important. But any of these organizations as well. I mean, I just think knowing and where to find this information, and as she had mentioned, how to ensure that you're, continuing to take care of patients even after they leave the hospital. So that'd be my recommendation.
Systems out there and I guess if you're going to a hospital or working at a hospital or wherever, a clinic or something, make sure that they are at least aware of what those sources of information, either the weather service or the emergency manager in the area. I'm in Kansas City, but I get alerts. Every weather thing comes up on my phone. It's going to be a hot, heat index day or whatever they call them. I should know. When they say the heat index is going to be 100 degrees or greater or something like that, I get those types of alerts, and I think those are good. Those would be great for people who have to visit people like yourselves.
Right.